And I'll be honest up front, I wasn't expected to give this talk. And actually, my first time I was expecting to give it is in NDC Oslo in May. So I have it like 75, 80% done for an hour speech. I'm like, okay, I can get 40 minutes out of it. And I've practiced it a few times at home. So it might be rough, but I think you'll learn something. Name of the talk, data modeling for software engineers. Getting your data leaders to smile, getting your engineering leaders to smile again, architects, product leaders, and even your organization. Back in the day, and I'm an old fart, we had data architects that proactively worked on your data models for you. She might talk to leadership. I had a data architect and her line was listen to learn. She would constantly be listening to her leaders, VPs, C-levels, what's happening, what's the business look like, what are their concerns, what are they looking to. She would also feed them information. It was a two-way street. She would talk to product, get the product roadmaps, understand, tie with what the leaders were talking about, and try and understand where product thought she was going with the next gen application, new business opportunities, things like that. She'd talk legal, because there are things you can do that are good, and there are some things that legal are like, yeah, that's not going to fly. Now, usually she had a team of data modelers. The data modelers would be assigned to specific initiatives. The initiatives would be happening usually concurrently, 2, 3, 4, depends on the size of your organization. And she would make sure that the data modelers learned at least what she needed them to know for their initiatives. And it's a two-way street. The data modelers would talk about problems, things that come up in meetings. They'd work on a data model that is going to be used for the application. She'd then work with the data architect, the database administrators, to make sure that the model that the data modelers and she put together actually got implemented in a way that makes sense. Sometimes the DBAs take great leaps of faith and like, oh, we'll do this, and the logical and conceptual model may or may not look like the production model, the physical. And then there's the software engineers who have to implement whatever functionality, whatever code on the initiative, explain the data model, explain some of the intricacies, and finally, she's working on standards. The standards that the organization are doing, how data is represented, what are the data types you're using, anything that's important domains that we want to be consistent throughout the organization. These days, we don't have any of that. Data architecture has gone from a very proactive, done in advance. I used to say that the data model was the only tangible thing that needed to be done before you started your engineering. Now, where we've empowered teams, Agile, things like that, data architecture is actually a reactive thing, a reactive task. And you, as software engineers, are the ones that are actually doing a lot of this. Now, I'm assuming that all of you develop software. I'm assuming all of you deal with data at some point. Very unlikely that most of you are doing modeling up front. You might model the data as you go along, but the upfront effort has kind of disappeared. And so that puts the control much more in your hands. But what are some of the concerns with this? Who's giving you the problem statements? Who's giving you an understanding of the bigger picture, what you're doing? You getting it from your product person who may or may not know all the parts of the business? Is it your manager who's just saying, yeah, just go out and code something. I got to have something. There's a sprint, we've got to fill it up, do something. I've heard a lot of that. Who's telling you what data you need to capture? Do you have a little bit of data that you need for this? Do you have a lot? Do you really know? Are you guessing as well? Because there's been no clear indication of what you need to do, how you need to do it. How about duplicative work? A data architect who is working with multiple initiatives, multiple data engineers, is aware of source of truth and who's doing what, and is aware of that perhaps there's two different teams, two different initiatives that are both seemingly capturing the same data. Okay, that's bad. Now you're in your own zone, you're in your own squad, your own team, your own sprint. Okay, I need X, I need Y, so I'll do it. And unless there's some communications between different teams, and sometimes it's good and sometimes it's bad, depends on the organization. You might have two different squads thinking they're doing the same thing, and they might do it in completely different ways. How about end-to-end usability? The data that you capture transactionally, that you're capturing for your application, for your microservice, for whatever. If you're a front-end application, you're doing a business process of some sort, it's some sort of financial or banking or travel, whatever the real purpose of it is. Where does that data flow through the rest of the organization, through the rest of the life cycle? Who's giving you that? In the past, it, again, would have been your data architect type of thing. Now, it's very much reactive because nobody's really, I can imagine where the data's going. I've got way too many years of experience. Others who are more junior haven't had that opportunity. They may or may not know where that data needs to go, what that data might be used for, might be able to guess. Or are you a data engineer who says, just get out of my way. I don't have time to think about all this. My sprint has started. I've got 3 story points. I got to get this done. Just get out of my way. Let me start coding. And unfortunately, we're encouraged to do this, quite honestly. You know, a manager who says, I don't care what you do. We've got to make it. We've got to move forward. You say, forward on what? Well, it doesn't matter. Product doesn't know what they want, so just start coding something. Okay, great. Am I coding the right thing? Yes, no, and maybe. Now, one of the things, this is a very famous ad, right? A diamond is forever. Toughest element known to man, scratches glass, all of that good stuff. But guess what? Data is forever. The code that you write today, or tomorrow, or next week, may not live past the end of the year, the end of next year, whatever the case is. Code is always changing. The data underpinning that code, the data that is used to run the business application, the analytics, it's forever. I'm aware of data that was captured decades ago that is still being used in some applications of places I worked at. The applications have dramatically changed. The applications no longer are fat client servers running on your desktop or are different forms of a web app. Now they're supporting mobile. The code that you wrote has evolved. It will always evolve for any number of reasons. The data often doesn't disappear. It's there forever. And it's there legitimately sometimes, sometimes not, but it's there. So who am I? Scott Sosna. I realized last night as I was going to bed, my name is not in this presentation at all. I thought that was really bad. So that QR code is my LinkedIn in case you need to find me. I've been an architect at many different places, enterprise solution application integration, but most importantly, I have been a data architect back in the day, long time ago. And even though I'm really not an active data engineer, data architect, I use my data skills almost daily, either for my own work or when I'm explaining work to others. My most recent job, the job I'm at today, I'm actually back as an individual contributor. I'm writing day-to-day code. Haven't done that in a long time. Enjoying it. Speaker, writer, mentor, obviously. I'm here in front of you today. I'm also a traveler. My wife and I love to travel. First time to Greece. There's just too many interesting places. Too little time. Now, I'm from the States. If my accent didn't give it away, I'm from a state called Minnesota, upper Midwest. Lovely summers, miserable winters. We usually talk about that there are 2 seasons, summer and construction. In the winter, we can hit, in Celsius, minimums of -30. In the summers, we can get up to 40 positive. So very wide, and some years, 250, 275 centimeters of snow. So again, winter and construction. So some of our goals for today. We're going to do data modeling 101. Design, implementation, decision, impact your solution's overall viability. We're going to talk about decoupling the data and how it appears to the outside world, and why that might actually be a good thing. And then we'll wrap up. I have no idea how long I'm going to talk today. We'll see how far I get in the wrap up. If we don't have time for Q&A and things like that at the end, I'll meet you in the hall, outside, things like that. What we're not going to do today, this is not going to be a data model tutorial. The truth of the matter is, every organization has their own ways of doing things. Data modeling is one of them. I cannot account for how you're going to model data in your organization. I also can't tell you how to turn your data organization, your organization into a data-first organization, setting up a chief data office, things like that. Those things usually go top-down, we're bottom-up. There's no way that we're going to go up to our CTO and say, hey, yeah, we got to be data first. Here's how it's going to happen. Most of the cases, it's not going to happen. I also can't help you define your career path necessarily about how to become a data engineer, analytics, blah, blah, blah. Again, where you are, where you want to go, the industry, the business domains you're in, the companies you're in, all of those things are going to be different. This is a painting that's at the Met Museum in New York City. And the painting on the left, obviously, and on the right is the description of the painting. When I look at that, there's a lot of different data points I can see. Top, who is the artist? Ilya Repin, Ukrainian, born in the Russian Empire, died in a city that was renamed after him, St. Petersburg in the Kokkola region. I can look at that and say, Kokkola, that's Finland. That's part of the part that used to be Finnish, and then after World War II became part of the Soviet Union. Biography information. You've got the name of the painting, the person who the painting is, his years of life. The painting was painted in 1884, oil on canvas. A description about both the artist, and then at the very end, a little documentary about this picture. How was this painting acquired? It was acquired by something called the Humanities Fund Incorporated. I have no idea what that is, in 1972. Its unique identifier, 1972.145.2. This one actually interests me a lot. My wife and I go to a lot of museums. And yes, I like the things that are there. I look at these placards, and I look at that 1972.145.2. That's actually unusual. Many museums would have 72.145.2 because, of course, Y2K was coming, and it wasn't until, for many museums, late 80s, early 90s, they're like, oh my gosh, our numbering scheme's going to fail. So somehow the Met was ahead of its time. Now, when I look at this, there are many different ways I can see of modeling that data. I can see, whether it's a MongoDB, JSON document, whether it's relational. There's some information that you're going to share about the artist across any one of his works that might be there. If I want to pull up all the paintings that are oil on canvas, how would I do it? So there's a lot of different ways of doing this. It just depends on what you're trying to do. And then again, once you capture it for this painting, how is it going to be used for other pieces of art? How is it going to be used in their overall catalog, things like that. So how is data used in your solutions? Some is pretty obvious. Persisted data, transactional data. Data that we store in relational and NoSQL database. It can be hierarchical, multi-value, object-oriented. Configuration files, sometimes even flat files. Your APIs. We are much more in an API-first world these days, where things are driven by RESTful endpoints, most likely, things like that. There's data in there. There's data in there. There's data in the requests, the responses, the headers, the query parameters. And quite honestly, the decisions you make are data decisions and will impact the livelihood and the likelihood your API is going to survive for a long period of time. Messaging, events, notifications that something important is happening. Again, life cycle changes. There's data in there. What are you putting in there? And even hardware-generated data. Your smartwatch. I worked at a company that did firmware for storage area networks. And there was metadata on each individual block of actual data. And decisions have to be made. You make good decisions? Great. You make bad decisions? You're in a world of hurt. So again, common ways that your application is, your data is used is in an application, supports end-to-end data business activity. Most of us, many of us are writing front-end applications used by end-user consumers, maybe within your organization, maybe outside your organization, doing the work that your business is up for. The data also might be used for reporting, aggregating it, so you can understand how the business is doing, maybe understand where you're succeeding, where you're failing, understand new business opportunities. You might be integrating with outside vendors who provide value, do something for you, might not be your core competency. Your data also might be your intellectual property. It might be what differentiates you from the competitors, might be your company's reason for being. I worked at a company years ago. It was in the American mortgage banking industry. She wasn't CTO, she was definitely high level in the organization leadership. She couldn't care less about whether our code got out into the real world. She couldn't care less if we walked away with our code when we left the company. She was more concerned about the data. She thought the data brought value to the company. And in fact, she was right. She was decades ahead of her time. But the data that we had actually allowed us to create applications that our competitors used to figure out the pricing of mortgages. They would send data to us. We would evaluate it with some of our data that we had captured as well as some of their business data. And we'd give them pricing on it. Sometimes they would decide to buy these mortgages on their own. Sometimes they say, yeah, you guys would be better off doing it. So we provided a service to our competitors, which actually helped us because we got paid for evaluating their mortgages. We got paid, and then we also often bought theirs as well. Again, my good friend, the data architect, Julie, she doesn't want to capture anything that there's not a reason for. And again, Mark Twain is a famous American writer. There's question marks whether he said it. I love the quote. You better know what you're going to do with it before you collect it. Julie would not allow anything into her data models that we didn't have a purpose to. Back in the day when you had data architects. And so this is really important because if you capture the wrong data, you're not going to be able to do what you want to do with it down the road. If you capture too much data and there's just garbage floating around, that garbage is going to be there forever, at least costing you in storage costs, if nothing else. So we're going to start, finally, 18 minutes in, Data Modeling 101. Now, back in the day, old school, yes, it screams waterfall. The data models always preceded actual coding. Today, when we implement code, we're actually on the fly doing a lot of data modeling. It's the persisted data, it's the published data, it's what we exchange with outside providers, it's what we cache, it's what we're measuring. And again, often we are making those decisions on the fly as we implement because we've been told we got to get something done. And this isn't, I'm not trying to do this every organization. I've just been at many organizations that upfront planning of data, sometimes at all, sometimes it's minimal, doesn't give you necessarily everything you need to know. One of the things about data models is, first, even when we did do data modeling, if they were created, they often weren't looked at, and now none of them are accurate. I want to talk about your IDE when you're coding. If I bring up a code base that I'm unfamiliar with, there's usually, hopefully, some code comments that you can look at to understand kind of what's happening. If nothing else, you can probably traverse the code, put different pieces together, see how all the parts together fit. Maybe there's somebody who's been around for a while that you can ask. There's really no equivalent in the data world of an IDE where you can just open up and get code comments. If you're in a relational database, what do you have? Well, you can do a describe of the table, and it'll tell you the name of the column, the data type, whether it's optional or not. Not a whole lot more than that. If you look at a JSON document, there's nothing there really supporting it, right? In the code, there might be a structure that has some sort of nullability mentioned on it, or it's got to be an email address, and you might be able to assume certain things, but there's no guarantee. There are no code comments. There's no data comment equivalent, right? And that makes it very difficult to figure out what the intent was. It adds complexity to reverse engineering. And I would say that any change you make in your code base as it pertains to data that you're working with, persisted, messaged, firmware, whatever the case, it's consequential. It's going to impact somebody somewhere. Minor as it might seem to you, it's going to break something somewhere down the road. One of the big things that I'm in favor of is consistency. And I brought this to my coding practices as well, but it's definitely there for data models. I would say data naming is more important than code naming because the data names are available to anybody who's looking at it, whether they're an engineer or not, whether they're technical or not. In my code, I can call something Blowfish Sushi Tuesday, Wednesday. I can declare a variable. And if it doesn't go outside that method, outside that class, who cares? Yes, it looks really bad. Yes, somebody else looking at it's going to laugh at you. But if you document it, it's pretty obvious. You don't have that luxury with data. How about data typing? Choose the data type and stick with it. Timestamps are the worst. You're storing it as a string. You're storing it as an epoch. You're storing it as a datetime structure. Are you using TF01 or natives for Booleans? How many decimal points on a percentage? Are you using an enum to represent a close set of values? Pick it and stick with it. Too many times I will see over here, let's just take a Boolean. It's TF. Over here, it's a native type. Well, TF, true, false, yeah, I can kind of see, but I've got to do a translation. The more consistent you are, the less bugs you're going to have because it's more understandable, more consistent, less time thinking about it. Have a consistent structure. Consistency reduces the cognitive complexity. Big words there. Let's just take an address, simple address, right? Address line 1, address line 2, city, region, state, postal code, zip code, whatever the country code. If you do it the same way every place, then as you go from place to place in your application, as you exchange data with other parts of your application, it's going to be pretty easy because they're all doing it the same way. If, on the other hand, they're dramatically different, you're going to run into problems. My classic example of that is, in the US, it's called zip code, postal code in Europe. But in the zip code in the US, it's either 5 digits or 5-4, zip or zip plus 4. I worked in an application that had grown out of control. It was a monolith. It's one of the reasons of my other talk that I gave here. The zip code was being stored different ways in different parts of the application. 5 long, 9 long, 10 long, 32 long, 128 long, 256 and infinity. I'm sorry, there is no postal code that goes up to 1 gazillion characters. Now, what happens when you try and take the 9-digit zip code, whether you're storing it at 9 and 10, you try and slam it into a 5-digit place. And better yet, the code didn't actually check length. Okay, service failure. Consistency on your structures and how you represent data is going to be huge. If you validate the data, always validate the data. Don't go and say, well, somebody else validated, I'm sure it's right here. Now, that validation may be, if you're using a database server, it could be a constraint on the table, the document, a field. If you've got the correct data types selected, you've automatically got built-in data validation. You might have some common libraries that everybody's supposed to use to validate certain business rules. These 3 fields must only add up to 100. If the 3 add up to something under 100, that's wrong. Over 100 is wrong, whatever the case is. Let's move on to standards. It's very ironic. I already had this in my talk yesterday, and I went back to my hotel last night, and I'm working because I'm 8 hours behind. My home is 8 hours behind here. So we're working, and somebody else was talking about a completely different area, and he put up this comment. Great. Let's have one standard for everything, and now we go from 14 to 15 standards. One of my favorite lines of all time, famous computer scientists. The good thing about standards is that there are so many to choose from. Well, guess what? Don't start creating your own. There are rarely needs for you to create your own. They exist at many different levels. Internationally, we have things like ISO 3166 for country code, 639 for language, 8601 for datetime formats. Why would you stray away from that? The country one in particular, I have seen so many implementations, and unless you're FIFA or the Olympics who recognize countries that don't really exist, why would you use anything else? I've never worked for FIFA. They recognize, the 4 parts of the United Kingdom as different countries. Okay, nobody else does. There's plenty of ISO standards you can use. There's industry standards. ICD-10, International Collection of Diseases. IBAN is the International Bank Account Numbers. If you want to participate in those industries, you're going to follow those. If you don't, you're not going to participate. It's that simple. Why would you create something else? Let's use the standard that the rest of the industry uses. Whoops, went back too far. Let's try again. Corporate standards are those that your organization has. It's just the way they do business. There's expectations from above. This is how we do things. Great. You got to follow them. You may have a need to go off. It better be a darn good reason, because if you try and do something that's not on those corporate standards, you're going to run into a problem. Businesses might be either, the best thing I can come up with is a business was inside a large conglomerate. I worked for a retail firm called Target in the US, and they had their way of identifying products, DPCID. You don't need to know what it is, you don't care, but every item that was sold in stores was represented by it. There was actually a need to potentially change that. Oh my God, it was miserable. We had to quit. It was just too ingrained in the system. There's also de facto standards, which really aren't codified anywhere as legal standards, but basically people follow them. ISBN are book numbers, International Standard of Book Numbers. But it's not really a standard, it's just that everybody seems to want to do it. So if you're a book publisher, you follow this, and now your books can be into retail stores that sell them. If you're not, you're probably selling them in boutique university publishing system. Microsoft Word doc, for by and large, it's a de facto standard. Every document system that you use, OpenOffice, things like that, will reverse engineer Word docs because that is the ubiquitous standard. Nobody's written a law saying so, but that's the way it goes. Other considerations. Never means maybe. No matter how many times I've heard this will never happen, it almost always has happened. Be prepared for it. It's going to happen. Whether you want to talk about that every person will have one and only one phone number, it's their home number. How many mobile phones do you have? I would say stakeholders often guess. Product people often guess. I don't know your experience with product people. Most of the ones I work with are just making stuff up as they go. It's really frustrating. Going back to the point above, they'll say it'll never happen and they haven't thought through all the things. Oftentimes, they'll just give you something enough because then your manager will say, just code something. You'll ask for specifics and they can't give it. Have you talked to clients? Have you talked to the world? No, we haven't. We're making this up. That often guessing is a challenge because you've got to try and make sense of it enough to when you're trying to develop. This is my personal pet peeve. I've had people give me solutions that are unworkable, and then I spend months trying to prove them it's unworkable. The biggest problem when you accept somebody's solution to their problem is that you're stuck supporting that solution. That's wrong. So I would push back. I would say, yeah, that's not right. And then trying to anticipate the future, even though you might implement selectively. There are ways, and we're not going to go into any of the details, but there are ways to do things so that you can actually set yourself up for success down the road. Could be as simple as saying, yeah, it's going to be more than one, even though they say it's only going to be one. I'm going to put an array in, even though the rest of the code is going to assume it's one. Data-wise, I'm going to start storing it as an array right now. Data-wise, I'm going to mark my phone numbers as mobile fax, and I can have multiples of it, even though the outside world doesn't know that. And there are some other things I don't want you to do. Don't ignore compliance and security. We're in Europe, GDPR. If you want to go out of business quickly, violate it. Don't abuse optionality or flags. I have seen some data models where every field other than the primary key or the identifier, unique identifier, is optional. And based on which fields you put in and maybe a enumerated value here that may or may not exist, you say, okay, these 5 might be required today, these 7 tomorrow. It makes the data totally unusable. It makes the coding extremely difficult because somebody adds another field. If we were doing this in a class model, You'd break these out into different classes with potentially a base class that had some things that actually have to be there all the time. Same thing with flags. Do you have 5 different flags that in certain combinations imply a state, or do you set up a state enum that implies the 5 different flags? I'm in favor of the enum. And then you can apply, make sure that the states of the 5 flags are correct combinations, because it's not 5 factorial, I'll give you that one. Oh, and one last thing on abuse optionality. I think it was SAP or PeopleSoft years ago, I don't know if this is their data model to date, their tables, every field, every property was required. If you had something that wasn't required in certain situations, that became another table. Absolutely everything was required. Now, that's going to the other extreme, and they end up with a lot of extra tables, but that's one way of doing that. Don't use business keys. I used to be the type that, okay, you've got a parent table A in a relational world, and then you've got a child table, and its key is A and B. And then you've got a child table, and the key is A, B, and C, ad infinitum. I've turned into the person that wants system-generated IDs. You might have some of these values at certain levels within the hierarchy, but I have found that system-generated keys are much more workable. And some databases, Mongo doesn't allow you to really have, Mongo has its key. You use it. From an enum perspective, don't codify all or none. So if I've got an enum that says marketing preferences, what are the different types of marketing schemes do I want to get notified on? If I have an all and I have a none, isn't that really the complete set and the empty set? And what happens now if I've selected all and I've added a new category? Well, you haven't given the user a chance to actually decide whether she wants to get that new category, because it's all. Well, then do we go back and update all our data to say, okay, it's not all, I'll do the set of the 3 previous ones and let the 4th one out? So too many times I've seen all and none codified. Too many times I've seen errors both in the code and the data as a result. Don't store localized data. Timestamps. How many times I see, in particular, date times stored with their time zone offset. Okay, when did daylight savings time happen in this locale with this time zone? How am I going to get my browser to show the correct time to the user based on their current time zone? I've also seen things where the description of like a state or an enum is stored rather than the enum value. You don't want to store localized data. And then don't repeat yourself. This kind of goes back to one of the original things I was talking about with data architecture. Making sure that you don't have 2 or 3 different teams that are all trying to manage the same data and collect the same data. There might be reasons to copy data to simplify other parts of it, but you really don't want to repeat yourself if at all possible. And then when in doubt, talk it out. Mad Magazine no longer exists, a comic strip back in the States, spy versus spy. The spies would think that they knew what each other was doing, what each other had capabilities-wise, and they try and blow each other up, and it always failed. And this gets into my discussion about coupling what your consumers see with what you actually persist as data. What did I want to talk about here? Yeah. So the more you keep your data implementation to yourself, the better, and the better it is. Some of this is, you'll see it in your RESTful endpoints, but I would say even in libraries that people have created over time. The more people know about your internal data, the more they're able to influence how easily or how hard it is for you to make modifications. This even applies to something like Snowflake. At my current company, our Mongo data is sent to Snowflake so people can do reporting and dashboards and analytics and things like that. If we want to restructure our data in any regard, we could blow up existing reports and dashboards because they are essentially tightly coupled to us. We've always talked about tightly coupled code, why it's a bad thing. We really want low coupling, high cohesiveness. Data is the same way. And I'm hoping that we can keep our secrets about our data to ourselves. There is no reason why somebody needs to know your exact data implementation. In fact, your data implementation may not even, how you do it may not look anywhere near what somebody's perceived vision of it is. There was a talk yesterday, I think his name was Victor, was talking about 7 tragic errors of RESTful implementation, and one was having the DTO, having a domain object used as essentially your DTO on your endpoint, your RESTful endpoint. Because, of course, then any change that you make to your domain object is immediately available to the outside world, whether you want it to or not, whether it causes security issues or not. So he wanted DTOs separate from domain objects. Somewhat of the same concept here, but I'll give you some other things. I want to keep how we identify an internal document, object, whatever, separate and hidden from the outside world. And let me give you an example. I worked at a place, and we were in the cloud. We had data in, we'll just start with AWS East, AWS West. We had a customer who wanted to move from the East to the West. It's a multi-tenant application, so we're sharing databases. Well, guess what? We had been letting the customer know the identity, the primary key of the document, of the object that they were working with. And they would send that in on their calls to do whatever they're doing, the APIs that we had exposed to them. When we moved the data from the East to the West, totally new IDs are generated, right? They're system-generated IDs. The ones that we already had overlap existing data in the West. So now what the client has no longer is real. What do you do? And we struggled with it for a long time. I don't know if we ever found a great solution. I think ultimately we had to tell the client, you've got to change all your internal references. A different way of doing that is to not tell the customer what that internal ID is and either generate a logical one just for that customer or have the customer actually say, when I'm creating this, I want to call this sushi blowfish. And you're like, okay, I'll start as sushi blowfish, and anytime they ask for sushi blowfish, we translate it into whatever it is behind the scenes. But by not having that identity in the outside world means that they're not able to subvert us when we have to do things. It's also possible that you might restructure your data in such a way that some of the primary keys that somebody had in the outside world go away, or new ones are needed, depending on you broke something up, you consolidated, things like that. I would keep them secret. I would keep the structure secret. They don't need to know how we're structuring our data. Now, this is a backwards compatibility with RESTful endpoints as well, right? Excuse me. Glad I only have 2 minutes left. How we store it internally, how we represent it externally can be totally different. And that's not a bad thing because it allows you to do the mapping, and you have to do that with backwards compatibility anyway. The flow, how the data flows in the back end, how it's validated, how it's mutated, how it's translated, how it's whatever, that's none of the business of your outside consumers. They don't care. They just want an answer. Don't let them know what it's going through necessarily. And the validation. The specific validations that you're doing should be able to change, right? Whether it's how you validate that the name is valid, how you validate that the range is valid. You might want to change those things. If the outside world knows, they can make implementation decisions of their own that assume that, and then when you change it, you're breaking their application. Now, there might be a difference between external consumers that are within your organization and external consumers that are outside your organization. You might, for simplicity, allow your own organization to work with your primary key, for example. I think that's probably a given. Structure, I still don't want them to know what I'm doing behind the scenes, because I've been burnt by that before, where they know specifically what that structure is. And as I try and break things apart, it doesn't work real well. Finally, this is something called HAPPY. It's a healthcare standard. This is the data you're storing in. I know for a fact that behind the scenes, the data that you're storing doesn't look like this at all. And I'm done because my voice is going, but there's a QR code. We're out of time anyway. There's a QR code to get the thing. thank you for putting up with my coughing, and thank you for being a wonderful audience on the first time I've given this. Hopefully you can walk away with something useful out of it, but I'll be around for a little bit before I go and play in Athens if you want to talk to me, and thank you very much.